work, etc. So today's lesson is on calculating the area of a trapezium. Okay, so I'm going to go through first of all like what a trapezium is and what the properties are, but hopefully we know that already because we've definitely looked at this topic before. Okay, so pause the video and copy the naughty words down, please. All right, and then just press play when you're ready. Okay, so a trapezium is it's a quadrilateral. So it's got four sides with one pair of parallel sides. Okay, so it's a four-sided shape with one pair of parallel sides. So the three shapes that I put there are all examples of a trapezium. Okay, so for this one, these two sides are parallel. Okay, the other two are not. On this one, these two sides are parallel. All right, and then the arrows are already on this one. Okay, and this is a different type of trapezium because it's a right-angled one. Okay, but remember the word parallel. Think of train tracks, right? Parallel sides are sides that they will never meet each other. Okay, so they're going in the same direction, the same distance apart from each other all the time. So, like if I look at these, for example, if I was to continue both of these lines that I'm drawing on now in the same direction, they would just stay the same distance apart from each other. They would never meet. Okay, so that's what a trapezium is. Now, to calculate the area of a trapezium, okay, I've shown you the trapezium there. So I'm labeling the top one as A. So the top side is A and the bottom side is B. And then I'm labeling this side here as H. Okay, so that's just a normal trapezium. What I'm going to do just to show you why, because there's a formula that we use basically for the area of trapezium, but I want to show you why that formula works before I give it to you. Okay, because hopefully it'll help understand why we use it. So if I've got that trapezium, okay, and I basically copy it, so I do the same trapezium again, all right, but this time flip it over and attach it to the trapezium that I had already, what you should see now is this is here the original trapezium that we had, okay, and this side then is I've copied that trapezium and I've just flipped it over and I've sort of slotted them in next to each other. Okay, and what you should see now for this big shape, so if I just change the color of the pen a minute, you should see that this big shape of the two trapeziums added together, right, just gives you one big rectangle. Okay, and we should already know that to find out the area of a rectangle, we just do the length times the width. All right, so what I've done here is this distance here is still H, okay, but then this whole distance along the bottom, okay, is now A plus B, because remember A was at the top, wasn't it, and B was at the bottom. Okay, so this whole distance here now is A plus B. So if I wanted to work out the area of that whole rectangle, I would do A plus B, yeah, and then times by H. Okay, but I only wanted the original trapezium, so I only actually want the area of this shaded part, don't I? Okay. So if I do A plus B times by H, that will give me the whole area of the rectangle, but technically I only want half of that, don't I? So I would half the answer, okay? So this is leading into why we use the formula that we do. I'm going to put some numbers into this now to hopefully make it a little bit easier to follow, all right? So this is the original trapezium that we had, okay? But instead of A, B, and H now, we've replaced them with those numbers. I'm going to do the same thing now. I'm going to copy this trapezium and attach it together to make a large rectangle. Okay, like so, right? So if this was 4 at the top here and this bottom one was 6, the whole thing now is 4 plus 6, isn't it? Okay, so if I want the area of the rectangle, right, so this whole rectangle is just going to be length times width, isn't it? Which in this case is going to be 4 plus 6 is 10, isn't it? Yeah, so the whole of the bottom of that rectangle is 10 and the height here is 5. So the area of the rectangle is going to be 10 times 5, isn't it? Which is 50. Okay, centimeters squared. Just remember the area is always the unit squared. But like we discussed then in the last one, I actually only wanted the area of the trapezium here, so only half of that. Okay, so if the area of the rectangle is 50, that means the area of the trapezium, okay, is half of that amount, isn't it? So 50 divided by 2 is 25. Okay, so the area of the trapezium is 25 centimeters squared. All right. So instead of having to redraw the same trapezium every single time and then attach it to the side and then work out the area of the rectangle and then half it, there's actually a bit of a quicker way, okay? But think about what we've just done. We've done A plus B, times it by H, and then half the answer, okay? So I want you to pause the video here and copy the diagram down and that formula, okay? Because this is technically what we've just done, all right? But we're going to use that formula without having to redraw the same trapezium again and then make it a rectangle, okay? So we're doing half of A plus B times by H, all right? And you'll see from the diagram, and you'll see from the diagrams I just went through with you, A and B are always the parallel sides, okay? So pause the video, copy that down, press play when you're ready to move on. So I'm going to do two examples with you now where we just use that formula to work it out. All right, so pause the video here again, copy the examples down, and press play when you're ready. Okay, so looking at this trapezium then, A and B are the parallel sides, okay, so the two sides that are never going to meet each other, which in this case is 12 and 8, and the height, okay, is always the distance in between the parallel sides, so that is H. And when you're labeling them as A and B, it doesn't matter which way around you do it, okay? So it wouldn't matter if you call 12B and the 8A, all right? So the formula that we've already wrote down is a half of A plus B times by H, all right? And make sure that you're doing plus A plus B in the middle here is not A times by B, it's always A plus B, all right? And we know all three of those things. We know A, we know B, we know H, so just substitute them in, okay? So we're going to do a half of 12 plus 8, okay, times by 9. All right. Then what I would say here is there's a few different ways you can do it. You can do 12 plus 8, okay, then times by 9 and then half it, or you can do 12 plus 8 and then half it and then times by 9. The way I would always say to do it is if the answer to your bracket comes out as an even number, okay, then I would half that first to make things a little bit easier. So in this case, 12 plus 8 is 20, isn't it? So this is a half of 20 times by 9. All right, so I personally just find it a little bit easier if this answer inside the bracket here is even, half it first. So half of 20 is 10. So all we need to do for this question is 10 times 9. Okay, units are in centimeters, so it's centimeters squared. All right, you would get the same answer if you did 20 times by 9 and then halved it. Personally, I just find it easier to do 10 times 9. Okay, half of 20 is 10, 10 times 9 is 90, so the answer is 90 centimeters squared. All right, one more example then. So looks slightly different, but it's still a trapezium. It's still got 4 sides where one pair of the sides is parallel. Okay, so press pause, copy it down, and press play when you're ready. All right, so this time we've got A and B are these two. They're the ones that are parallel that will never meet each other. And then this side here is H. And again, it doesn't matter which way around you do A and B. So I'm going to write the formula down again. A half of A plus B times by H. Then substitute in what we know. So A is 10, B is 15, H is 5. Okay, so this time, once I write this out again now, the answer to the bracket is 25, and then 10 plus 15 is 25. And then we've got times by 5. So remember I said in the first example, if the answer to the bracket comes out as even, then half it first, okay? I've picked this one on purpose because sometimes the answer to the bracket doesn't come out as even. So in this case, it's odd. So I would avoid you multiplying by a decimal because it's just slightly harder than some of the other questions. All right. So what I would do personally for this one is I would work out 25 times 5 first and then half it. Okay, because it's easier just to half a number to make it a decimal than it is to multiply by a decimal. Okay. So for this one, I would do 25 times 5 and then half the answer. Okay. So we're doing a half of 25 times 5 is 125. Okay. So we're doing a half of 125. Okay, and if you need to split this up to help you, and that's fine, I would do half of 100, okay, half of 20, half of 5, or whatever way you want to do it. Okay, or half of 100 is 50, isn't it? Half of 25 is 12.5. 50 plus 12.5, 62.5 centimeters squared again. Right, so just a personal preference for me, if this number here in the bracket is even, I always half it first and then multiply. And if this number is odd, I always do the multiplying first and then half afterwards. Okay, if you would half this first though, then we've got 12.5, and 5 times 12.5 is still 62.5 anyway. Okay, so main task now. All right, I just want you to pause the video there, have a go at these, and then once you're ready to go through the answers, obviously press play. All right. Okay, welcome back then. There are the answers there. Okay. In a few of these, especially the last two, I've given you more information than you need. Okay, but you're smart enough to work that out. Okay. Right, checking question now. Pause the video again. Copy this down. Have a go at the checking question, and then when you're ready for the answer, just press play. All right, welcome back then. So the area of the blue shaded section, and the best way to do this is to work out the area of the two separate trapeziums. Okay, so you've got a small white trapezium there, and you've got this larger trapezium here. Okay, so the best thing to do is work out the area of the large one, then work out the area of the small one, and then take them away from each other. Because if you take the small one away, you're left with the blue shaded section around the outside. Okay, so the large trapezium, I'm just going to input the numbers. All right, you've got A here, B here, and that's H. So our formula would be a half of A plus B, so 20 plus 30, times by 16. Okay, so for this one, 20 plus 30, yeah, that gives you 50, doesn't it? Half of 50 is 25, so we're doing 25 times by 16. So just do the box method if you're unsure, okay? Or just do 25 times 10, which is 250. Then 25 times 6, which is 150, yeah? And then just add them together. So that should be 400. So the area, this is in meters squared this time, no, yeah? The area of the large trapezium is 400 meters squared. Oh, my bad. That's actually the small one, isn't it? I've just done the small one. That doesn't matter. We'll do the large one now. So that's the small one, sorry. The large one is using these values now. So A, B, and H. So let's do that one now. So ignore what I said earlier. The small one's 400. The large one is what we're working out to be now. So that will be 24 plus 34, and then times by 20. Okay, so 24 plus 34 gives you 58. So half of 58 is 29. So we're doing 29 times by 20. So again, do 20 times 20, do 9 times 20, add them up. That should be 580. Okay, so the area of the large one is 580. The area of the small one is 400. So that means the area of just the blue shaded section, which is what the question is asking for, is taking those two away from each other. All right, so 580 meters squared minus 400 meters squared equals 180. Right? So just a little bit more thinking, that's all, but work out the large one, work out the small one, and then take the small one away. So imagine you were taking this one out, okay? Then that means all that would be left would be this shaded section around the outside, okay? So hope you find that easy to follow, and yeah, see you soon. Thank you.